All right. People are still streaming in, but we'll just go ahead and get started. Welcome everyone to 350 Colorado's Regenerative Agriculture and Local Food Committee's monthly webinar. Tonight, we are really excited to be talking about biochar, something that I will admit I'm kind of a novice on and will be learning just as much as everyone else on the call tonight. As we gather tonight, we want to start by honoring and acknowledging that the land of what's now called Colorado is located on the traditional territories and the ancestral homelands of the Cheyenne, Arapaho, Ute, Apache, Lakota, Pueblo, and Shoshone nations, amongst others. Further, we acknowledge the 48 contemporary tribal nations historically tied to the lands that we are on tonight. I hope that wherever you're calling in from tonight, you're warm and safe and well. It's snowing here in Denver, which is beautiful, but a little late in the season for my preference. As I said, tonight we're going to be talking about biochar, and we are joined by two experts, Kathleen Draper and Gordon West. Here's how our event will flow tonight. Kathleen will start us out with a general overview of biochar. Then we'll hear a little bit from Gordon on one approach to making biochar and the benefits of that. From there, I'm going to show a video that our committee made on how to use biochar in your own garden, which I'm really excited to share with you. So as a reminder, we are recording. Just want to let everyone know that. After the presentations and the discussions, we're just going to move into a full question and answer discussion. So at that point, please do feel free to come off video, come off mute, ask your questions. We'll probably have about 30 minutes for that. So it should be a really robust discussion. With that being said, I'd like to introduce Kathleen. Kathleen Draper is the board chair of the International Biochar Initiative, and she is the owner of Finger Lakes Biochar, which is focused on biochar activities in New York State. She is also the U.S. director of the Ithaca Institute for Carbon Intelligence, which has a global focus on biochar activities. She is the co-author of Burn, Using Fire to Cool the Earth, as well as Terra Preta, How the World's Most Fertile Soil Can Help Reverse Climate Change and Reduce World Hunger. Thank you so much for joining us tonight, Kathleen. I'm going to go ahead and hand it over to you.
Thank you. Let me just try to load my presentation here. First of all, I'm going to say that I'm going to start at a very elementary level, but I know there are at least two people who are well steeped on the topic of biochar on this call that aren't presenting. So hello, Ron, and hello, Mike. So in my few minutes, sorry, I'm trying to get this to load as a slide. There we go. I want to cover just a couple of things. But first of all, let you know that I often use this picture of burnt toast to describe biochar in the simplest way possible. So imagine that you have some form of biomass, you put it in an oven, you close the door, you crank up the heat, and you burn it. What this is actually doing is getting rid of a lot of the volatiles, and you're left with a very high carbon material. And it's not really very tasty. And so that is partially what contributes to its durability in the soil, because microbes don't really view this as a food source. So we know that biochar can last for decades, centuries, and even millennia. So what I wanted to cover at a very high level is, what is it, what can you do with it, and why you should care about it from a climate change perspective. So I usually use this slide to describe and differentiate between some of the carbon cousins. I could add graphene here and a few others, but the ones most commonly known are charcoal and activated carbon. And biochar kind of fits in the middle of that. And they all look very, very similar, but there are some differences that it's good to be aware of. And the first is what you can make it from. So traditionally, charcoal comes from wood waste. It can also be made from sawdust, in which case you'll probably have some binding agents in it. On the other end, activated carbon is often made from petroleum-based products, but it can be made from renewable, renewable biomass, such as coconut shells. When you consider biochar, it can be made from a very wide variety of organic material, from manure, sewage sludge, crop residues, and it all produces biochar that have very different qualities. The other area that differentiates these carbon cousins is what you intend to do with it. So obviously charcoal is used for cooking or for heat, Activated carbon you probably recognize as being most commonly used for things like filtration, sometimes odor control. It's also, if you have ingested something toxic and you go to the hospital, it's what they'll give you to help pull out those toxins. It's also sometimes used for remediation, but that can be a pretty expensive material. So biochar, as I'm going to go into in the next slide, has traditionally been used as a soil amendment. That's not to be confused with a fertilizer. But we're in the last couple of years seeing a whole push to create more markets that have been either traditionally activated carbon markets or even some non-traditional markets for biochar. And the relevant qualities that differentiate these carbon products is that for charcoal, you're basically just dewatering it at a fairly low temperature because you want to retain as much burnable mass as possible. When it comes to biochar, depending on what the end use is, you may want characteristics such as adsorption or what's called cation exchange capacity, but fundamentally, we're looking at carbon sequestration. So it has to have a certain durability, which is defined by what's called the hydrogen to carbon ratio. I'm not going to have time to go over all of these because I only have a limited time, but I will be giving these slides to you all if you want them. And what for me is the most important thing here is the sort of life cycle assessment, or the carbon footprint of these materials is vastly different. At best, you can consider charcoal to be carbon neutral, but we do know that in some parts of the world, it actually is leading to deforestation. Because of the energy required to make activated carbon, it can be, it can cause a lot of greenhouse gas emissions. And biochar, on the other hand, can be considered as a carbon removal or negative emissions technologies, but that's not always true. So a couple more things just to note about biochar. Even though they all look relatively similar, especially when they're powderized, they have varying physical, chemical, electromagnetic properties. So it's important to understand that, when we say the word biochar, there's actually 1,000 different types of that material. And most people want to know if it is considered organic. For the most part, it is. The one exception which they are trying to change is biochar made from manure. For whatever reason, that's still not considered organic, even though the manure itself can be considered organic. The other question everybody always wants to know is how much is it? That answer is very variable depending on what kind of biochar you're getting, what the feedstock is that was used to make it. But the prices are definitely coming down, especially as production is going up. And then if you want to make it yourself, which is very doable, the thing to understand is you're generally looking for a dry feedstock. And with some technologies, pre-processing is necessary. And just to point out, this is the wall that's behind me. That's my biochar wall that I made a couple of weeks ago in my house. It's got 50% biochar, 30% sand, 20% clay. So this is a graphic I did about 5 years ago. It was done to try to describe the different markets for biochar. If you start at the lower left and circle around, this was kind of a history of it. And this will describe how much a certain market might be able to absorb, what the price point for those markets might be, and the commercial readiness. That said, I totally missed the market in some areas. And up at the top left there, you'll see in the US what some of the big pushes are in terms of markets. And if I had to say right now what the biggest market is for biochar right now, it's compost operations. And I can go into why that is later if people are interested. But the one thing I'll note here is that I used to just dismiss the carbon offsets as being something that really mattered to the biochar industry. But in the last 2 years, biochar has been accepted on 2 very small carbon removal marketplaces. And the price that people are getting for a ton of carbon dioxide equivalent is orders of magnitude higher than they're getting for carbon offsets. And companies like Microsoft are investing. So the demand for biochar as a durable carbon removal product is really starting to soar. So why should you care about it? Well, in 2018, the IPCC for the first time talked about negative emissions technologies and the fact that we need to remove, we can't just reduce. And they actually highlighted biochar as one of only a few different technologies that might be able to help significantly with removing carbon. I sort of differentiate the top three from the bottom three as natural solutions. And the bottom three are, some of them have been prototyped, but a lot of it has not been commercialized, or at least at a economically viable level. And the other way I like to describe biochar in terms of the CDR is that it's safe. We've been doing this for thousands of years in indigenous communities across the world. We know it's scalable from a backyard kiln to industrial scale, and it's shovel ready. It's been proven. There's dozens of technologies out there right now that you can use to make biochar. My caution here, I wrote a blog post a year or so ago about the 5 stages of falling in love with biochar, is that when you first discover it, you know, you get really hopeful and you start telling everybody this is the solution, and then very quickly you'll probably come to the stage where it's overwhelming, because there's so much research being done on biochar and so many different projects looking at commercializing it in different scenarios that it can seem overwhelming. And I say to people, if you really want to make a difference in this industry, it's important to focus on either a specific scenario, a specific technology, or a specific type of feedstock. Learn as much as you can and educate others, because that's what we need most, I think, right now in the industry. And if you're interested in additional information, Michaela just mentioned the IBI and a couple of the books that I've written, but also the U.S. Biochar Initiative is very active these days. They're working heavily with the U.S. Forest Service. Ron Larson, who is on this call, has been on the USBI board longer than I have. And then also the Biochar Journal, we have sort of layman version of biochar information there. So I think I probably went over 5 minutes, but that's a general overview.
Thank you so much, Kathleen. That was fascinating. I really love that graphic that you shared of, you know, the range of what you move through. I feel like I personally am somewhere in between that exuberant and evangelical phase. So I appreciate the caution moving forward. I now would love to introduce Gordon West. Gordon is the founder of Trollworks LLC, which is a company committed to biomass process technologies on the community scale, including biochar. Trollworks founders have been leaders in community-based appropriate technology for over 30 years. In addition to the climate, land stewardship, and sustainable bioenergy systems, Trollworks builds a variety of other technology systems that enable land-based communities to diversify economic opportunities, supportive of land stewardship and regeneration. The floor is yours, Gordon.
That was a great intro. I wish I'd written it. Actually, my friend in Boulder, Brett Karen, wrote that. I've been working with him for about 20 years. Yeah, in fact, what I wanted to focus on, you folks might wonder when I'm going to start talking about biochar, because I sort of get to that at the very end. As was mentioned in the intro, I've been working in community-based forestry, forest restoration for 30 years. We were a Ford Foundation community-based forestry pilot project from 2000 to 2005. And during that time, I established pretty good networks all across the US around community-based forestry. Community-based forestry, in a nutshell, is the attempt to create circular economies that are localized. It's quite different than the standard commercial, industrial, corporate models of using feedstocks to make products that you sell in as large a market area as you can. What we're actually focused on is making the tools and equipment that people in local communities can use to use the, I call it liability biomass, like forest waste, wildland, urban interface thinnings, ag wastes, all sorts of woody biomass. People in the communities can use that, maybe even band together in a co-op form, And our equipment is designed to integrate into that community circular economy. I get inquiries, people want to buy systems. We're not really quite in that mode of production yet, but usually the first thing they want to know is how much biochar can it make? And we don't actually focus on that end of it. In order to do this integrated approach, we're actually building machines that utilize burning the syngas for energy to heat buildings or for process heat. Like process heat could be in a brewery, someplace that needs quite a bit of heat energy and is currently using fossil fuels. We have one guy that we're beginning to work with who has a pecan processing plant in Las Cruces in southern New Mexico. And they're burning natural gas at 2 stages in their process, because the first thing they do is sterilize the nuts by heating them in a near boiling water bath. And then they have to dry them. And they're burning natural gas. And they produce an immense quantity of nutshells. When they're in full production, they make 60,000 pounds of nutshells a day. And in those, they give them away because it's liability biomass. They don't have anybody who will buy them. The main customer is a cement plant manufacturer who burns it for the ash. They don't even burn it for the energy. So the ash is a component in their cement. So we can get semi-loads of pecan shells delivered to where we are for the price of hauling. And meanwhile, these guys are spending $60,000 a year on natural gas. So we're looking at installing some of our, I call them biochar boilers, that they won't necessarily replace the natural gas units, but they'll be running in parallel. And so they can save $60,000 a year and reduce their liability biomass. They can convert their liability biomass to a profit center. And they know all the pecan orchards, so they can sell the biochar to the pecan orchards. So that's kind of an example of a pretty tight circular economy. We're very interested in that, but we're also interested in small communities who maybe were forest products, wood products dependent, and who are now struggling. Rural communities like mine, practically everything we have comes in from the outside on a truck. And this is one way to create a lot of different products. And Kathleen showed quite a few of the opportunities, but there's even more. And building products, using biomass in other ways, not just to make biochar. I come from a background of being a building contractor and woodworker. And typically a normal house, there's about 70% of the money is spent on materials, 30% on labor. And of that 70%, probably 90% of that is bought from somewhere else in the world and shipped in. But we've done a couple of test projects where we've used chipped biomass and some non-Portland cements that don't have a big carbon footprint. And we can skew that 70%, or let's say, well, I'm into math, which I can't do right now. we can get rid of about 90% of those imported materials and replace them with local materials. And that has a tremendous impact on energy to ship, even bigger impact on our local community, because money not going out is actually worth more than money coming in from sales. I won't try to explain that. So we've developed a machine that's it's very focused on utilization of the syngas or the smoke to make energy, and they're very clean. Syngas is not that different from natural gas. Its density is less, so you have to handle it differently and burn it differently. And the byproduct is biochar. So one of the interesting things it does for the biochar angle is, because we haven't started up a large company with a big capital expenditure to try to manufacture large quantities of biochar to export. And then so that puts the bigger companies in a position of how do they get large quantities of feedstocks reliably, and how do they market them? And Tom Miles, who's, I guess he's now the executive director of USBI. First time I met him was at Aprovecchio Stove Camp. It's a little place in Cottage Grove, Oregon, where they focus on making small stoves for third world countries that are cooking on, 3 stone fires and other ways. And when he first introduced himself, he said, well, my claim to fame is I'm a guy who participated in helping to start up 2 $20 million biochar operations that both went bankrupt. So we don't want to do that. We're not even interested in that. Other people are, and that's fine. But so if you could put up that picture, I'll show you the equipment, kind of talk about that with the picture. So
Can
this
you
is
see that
not,
okay?
yeah, I can see it.
Okay,
Everybody
perfect.
else? Yeah. So it's a pretty simple thing, really. It's a continuous feed T-LUD, which is a top-lit updraft method of making biochar. There's other methods, closed retorts that you cook the biomass with external heat. In a T-LUD, you burn some of the generated smoke to create the heat to do the pyrolysis. I actually put the wrong picture up here. That's okay. The big tank is just a feedstock hopper. The angled tube is a continuous quencher. So when the biochar comes out, it's hot. And if you don't cool it off right away and it's exposed to oxygen, it'll continue to burn to ash. Unfortunately, what you can't see, or maybe I'm hiding a trade secret, is a cone-shaped pyrolyzer, and it's only about 3 feet tall, and at the top diameter it's about 18 inches, and that will process about 100 pounds of dry feedstock or dry biomass in an 8-hour day, and it will produce about 200,000 BTUs of heat per hour. And for people who don't know how to equate that, I live in a 1912 brick craftsman house, and it's kind of big, and it used to be heated with coal, the coal boiler, and it's the peak load on that is about 50,000 BTUs an hour. So the coldest part of the winter on a cloudy day, we need the capacity to generate 50,000. So this unit you're looking at would heat 4 old drafty homes. We're not targeting homes at the moment, but right now we're mostly looking at greenhouses. So this makes it pyrolyzes the biomass, which we pelletize, and the reason for that is so that we can make all biomasses equal, and because it takes up a lot less room. The density of a pellet's about 40 pounds per cubic foot, and the density of a pine wood chip's about 12 pounds per cubic foot. So we can squeeze everything down. And in a central processing facility like ours, it's called Gila Wood Net. It actually started as a nonprofit in 1998 to do forest restoration. Well, we use that heat of burning the smoke to dry the incoming biomass. And then we pelletize it, and we can put it in super sacks or small sacks and use it when we need it. And this machine uses about 20% of those pellets. So you get a pellet production of about 80% of the feedstock. And there's another version of this, which would go in a greenhouse, where the heat is used to heat the greenhouse, and the feedstock is the same pellets, and they can run 24/7. We're not quite to the point where they can run without an operator 24/7, but it's getting pretty close. So we basically have 2 community systems. One is the core facility that processes local biomass. The other systems are on, let's just say, buildings to make it easy. Currently, we have 5 pilot projects going. One of them is at Northern New Mexico College. They have a remote campus that used to be heated by propane. They closed it in 2015 because they couldn't afford to heat it with propane. And I met them in about 2018 and said, well, why don't we write a grant proposal, and you can heat these with pellets made from local waste biomass and make biochar, and you can start up your soils lab again and your ag curriculum. So we're doing that. More recently, we participated in a NRCS Conservation Innovation Grant proposal that was funded. And we're going to put one of these biomass boiler units on 4 greenhouses in food sustainability operations. 2 of them are inner city, one's in Detroit, one's in Cleveland. And one is on the Navajo Nation, and then one is at our farm here in Silver City. So our focus is on heat, but we're generating actually a lot of biochar, and there's no real pressure on us to try to market that biochar at any sort of scale. So it's a great way, I think, for communities to start to make biochar, to get it in use. The more people you get using it, the more educated people are, and all the benefits are distributed to all of those people instead of, to build a big corporate office building in San Francisco. So that's probably enough for now.
Thank you so much, Gordon. That was fascinating. I really appreciate you getting into some of those more technical details. I think we definitely have some questions coming in on the chat already, and I think we'll have some more as we move into the discussion. I personally would love to hear about some of those food sustainability applications that you mentioned towards the end there. Cool. So at this point, we are going to share a video that we made within our committee. And I just want to thank Janice Hallowell for her enthusiasm in making this video. She's featured throughout. And then also Rebecca Stobie, who edited this video and included the music from her own band. She's very talented. So I'm going to go ahead and share this. And if for some reason sound's not coming through or anything, you all just let me know. And all right, everyone can see that okay? All right, here we go.
So there it is. It's really light, like beautiful black diamonds. It's really, really clean product. So this is our compost pile that we inherited when we moved here 10 years ago. And we've added to it, and we've taken out of it, but mostly we've added to it and kind of ignored it. So it's really rich, it's really finished compost. But now we want to add biochar. And so here's the biochar. We bought this biochar. You can make it. We opted not to, because if we made it, we'd have to let it cure out, and we don't have time for that. So we bought it from Biochar Now, and their their biochar is USDA approved and EPA approved. So it's really ready to go. But still, we're going to put it in the compost to let the microbes inside the compost take up residence inside of the biochar, because the biochar retains the structure of the living tree that it was made from. And everything that was a living cell is just an empty space now, and the microbes love to live in there. So what we're going to do is, it's really light,
So when you're putting the biochar in, what's your ratio? How much biochar to compost are we doing?
The people at Biochar Now told me 1 to 10 of biochar to compost. I've heard it higher, so it's just approximate.
So while we're waiting for Howie to finish digging, can you tell me a little bit more about the compost? What goes in it? What's the process like for people who don't know how to compost at home?
We've always been lazy composters around here. And this compost pile was just basically kitchen scraps, and then various kinds of manure. Like we had a big load of rabbit manure that we put on it one year, and we put sheep manure on it. And then I think we turned it a couple of times, and look how beautiful it is. But that's over 10 years. If you wanted to go faster, you got to put those layers on, and you can be creative with the layers to a point. You want to have manure, you want to have, you know, green things like kitchen scraps or garden waste, as long as it's not woody waste. And you want to have water, and you want to turn it.
You got two good arms too. Honey, ain't that the truth? Honey, I got two good legs. You got two good legs too. Honey, ain't that
Put the biochar into your compost all the way along the line. It's a good idea. Hopefully we'll get some snows over the next couple of weeks that'll really help it all get, you know, hydrated, because biochar absorbs and regulates water and moisture in the soil. So it's very dry, as you saw when we took it out of the bag. So it's good to get it wet. It helps the microbes grow in it. And all those things can just take up residence inside of the biochar cells. It's on a microscopic level. It's a cellular level thing.
And Janice, why wouldn't you want to put biochar just directly in the soil without putting it in the compost first?
So I was told that the very best way to use it is in your compost, because it needs to have the organic material. You know, things that microbes are already growing in. So here's another way you can compost. This is our newer, more civilized compost pile. And, you know, it's a box that opens up in front so we can dig in there. And you can see it's just kitchen scraps pretty much, and maybe a little bit of compost from the other pile is already in there. So I've got a little bit of char here, and I'm going to just make a layer of char and kind of stir it into the kitchen scraps and what's in there.
got a million thoughts running through my mind. Honey, you know the kind. Well, I got all these words, so don't you?
You know, it's like there used to be a dessert called a fruit compost, and they called it that because they just layer the things on, you know, in attractive layers. And composting can be as simple as that. You just make layers of stuff, and then at some point you stir them up and keep them wet. So mostly the manure is going to add to the compost, and it's going to cover up the biochar so the biochar can absorb microbes from the manure and the compost. And over time, with snowfall and rain and cold and hot and water from sprinklers and things like that, it'll percolate into nice, rich, loamy compost like what we've got over there. Okay, so a third way that you can do this biochar is to make tea, compost and biochar tea. What I did was I took this 5-gallon bucket, this one, and I mixed, you know, 1 part biochar, 2 parts compost, and then like about 3 parts of water. Stirred it all up and just let it sit. And so today we're going to try and put the tea from it around this little mountain cherry, which is sort of struggling, and I wanted to put a liquid biochar on it because the grass just grows right up to it. We don't have a cultivated area around it where we could dig it in. So I wanted to try just putting like a liquid, a tea. And then of course this stuff that's in the screen, this more solid stuff, we could put this in the compost, and it'll be really great.
Ain't that the truth? Honey, I got 2 good legs. You got 2 good legs too. Honey, ain't that the truth?
Okay, so a fourth way you can use biochar is you know, you can buy compost in bags. And we have this area out here that we're trying to get the soil better before we plant it with trees and bushes. So this is where we're using the store-bought compost instead of our home.
Keep it coming, keep it coming, keep it coming, love. Keep it coming, keep it coming, keep it coming till the morning comes. Keep it coming.
We're gonna let it sit for a month, and then we're gonna plant trees and bushes in here. It should be beautiful.
Okay. I hope everyone enjoyed that. I really love that video. I think it's great, and hopefully it gave you a little look into some of the practical applications. We do have the experts on here, Kathleen and Gordon. So if we got anything wrong, please feel free to chime in and correct how we could do it better. And thanks again to Janice and Rebecca for that. So let's just go ahead and jump right into discussion at this point and questions. I know there are a lot of questions coming in from the chat. Before we go into any of those, I just want to invite anyone to just go ahead and come off mute, come off video, and ask your questions directly. So I'll just open that up for a minute while I sort through which questions here in the chat to prioritize. Don't be shy.
So
Speaker,
Oh, two at a time. I heard Peter first, I think.
where do you purchase those bags of biochar? Where would you find that?
Janice, I saw you come off mute. Go ahead.
Yeah.
Or one of the panelists too.
Yeah, I got that biochar from Biochar Now, which is in Berthoud, Colorado. He has a lot of kilns and a lot of product. I think you can get biochar from local nurseries, but I'm not entirely sure, where it comes from or what it is. I know you can drive to Berthoud and pick up bags. I bought about 12 bags. Each one is of 1 cubic foot and costs about $13. And in that compost pile, the big compost pile, it measured about 6 feet by 8 feet. So that's 48 square feet by 1 foot depth. So it's right around 48 cubic feet. So we put 5 bags in that compost pile.
Good. Thank you.
You're welcome.
Now, is that a, and I'm getting feedback from my friend who's outside, is that ratio determined by a scientific method? That's my first question. My second question is for Gordon. And are those machines that he showed us and talked about commercially available?
I think
Well, we're
Gordon
working
will
on
answer
that.
this whole thing because I think, Gordon, you probably know more about ratios than I do anyway.
Okay, what was the ratio question?
Question
Are they
is,
backed by
that
science?
1 to 10 ratio,
1 to 10. Yeah.
and also for the T, was that scientifically determined?
I got that tea recipe, sorry, out of a book on gardening with biochar.
But there's an awful lot of science around the blending ratios, and it's generally advised between 5 and 15%. And so a lot of the reasons that the compost industry is interested in biochar has to do with the fact that it heats it at higher temperatures, which means it can burn off more pathogens. It can help immobilize certain contaminants in the, say, manures, like herbicides or pesticides. It can reduce a little bit the time it takes to actually get your compost ready, and it holds on to the nutrients more than if you don't have biochar in it, and it provides a kind of bulking agent which doesn't decompose. So there's a lot of research being funded by the compost industry right now on the use of biochar.
Our view, our approach on using the biochar, and we're not as focused on, developing uses. There's lots of people doing that, and we're pretty overwhelmed with the amount of stuff we're doing already. But one approach is to view the biochar as a carrier distribution. I call them airstream trailers for microbes. We're working with a few fungal dominant compost researchers. David Johnson, he's spends his time at Chico State and also New Mexico State College, or New Mexico State University. And then Elaine Ingham's been working in that field for a long time. So our favorite approach to try to get people interested in is to load the biochar with beneficial microbes. That's just one thing to do. I mean, you can load it with nutrients, and it stores water. So if you're looking at it that way, and I've also heard what Kathleen said, that, and what you all are saying, that 10% is probably a safe loading level. If you're talking about biochar, you might be able to do higher, but if you don't know, 10% is probably safe. There was the question about the machine. I forget what that was now. There's a question in the chat wanting to know about the pelletizing step. It does take a bit of energy, electrical energy, to make pellets. We feel like for our system and what we're trying to accomplish and the benefits we gain by pelletizing, that it's worth that energy. If you did a energy balance, you probably find it's maybe a 10% input of, if you're buying coal-fired power plant electricity, it's probably a 10% loss in carbon. It's possible to do this in the woods, but being in the forest restoration business for 30 years, I'm not much in favor of doing complicated or those sorts of processes in the woods. You can have problems with permission to do it. You have to take all that gear out in the woods. If something goes wrong, you got to go back to town to fix it. So we like to think the best thing to do is just chip waste biomass in the forest and haul that biomass in. So I guess that answers that one. Oh, and yes, you can do it with all kinds of forest thinnings, and you can use it to do fuels reduction to mitigate for forest fires.
I was going to ask a little bit more about that, Gordon and Kathleen. I saw this question come in from Celeste asking about the way to use the hundreds of acres that have been burned in Colorado, historically, but also in the last few terrible fire seasons that we've had here. And I'm wondering if it's possible not just to use the acres that have already been burned, but also maybe as a method for forest fire mitigation, doing coaling. And then also if this could be a use of the beetle kill trees as well. So if you guys could maybe talk about that a little.
Yeah, that's how biochar now in Colorado started out. They were, taking a lot of that beetle kill pine. And I think I may have mentioned the U.S. Forest Service is very interested in biochar. They are one of the primary funders for the U.S. Biochar Initiative, and they host a free monthly webinar series on various aspects of, this, how it's being done, what the benefits are, what kind of uses that kind of biochar is being used for, and things like that. So I think if you just Google the U.S. Forest Service and biochar webinars, you can view the past ones or sign up for future ones.
And there's another example. We're just starting to work on doing a pilot project for Boulder. And one of the main interests is in what do you do with the ash trees killed by the emerald ash borer, because that material pretty much has to be incinerated to interrupt the beetle cycle, the bug cycle. And they're paying $70 a ton to dispose of it, not counting the cost of collecting it. And in this pilot, a local tree service company who already has a sawmill would aggregate the biomass. They already chip stuff to, and they would saw up the better ash logs for lumber. They would use burning the syngas to dry the lumber. They would also use it to dry the biomass and probably make pellets. And both the Boulder City and county are interested in heating some of their municipal buildings with these systems.
Gordon, I just heard you use a term again that you used before and it was asked about in the chat. Can you explain what syngas is?
Sure, it's short for synthesis gas, and it's generally used for the gases that are driven off during gasification. So you can gasify biomass into all gas, but when you take it that far, you're also gasifying the carbon, and you're creating either CO or CO2. In pyrolysis, we're controlling the temperatures, and we're really only driving out the volatiles contained in the biomass and leaving behind most of the carbon. It's still called syngas. I like to call it smoke because people know what that is, but I've been warned by some more science-based colleagues that don't call it smoke, but it's smoke.
And can you also maybe tell us what pyrolysis is?
Yeah, so if you heat woody biomass for making biochar, it's generally say between 350 Celsius and 900. That turns these volatile chemicals, which you might think of as pitch, into a gas. And that gas comes off as smoke, and it leaves behind the biochar, which would need a higher temperature or more oxygen to fully gasify. And by doing it in a low oxygen environment, you're actually preventing that oxidation of the carbon.
So the visual again is putting it in your oven, closing the door so it doesn't have oxygen.
Cranking up the heat. So biochar now makes theirs in closed retorts, so they're big batches. And I don't know that. I think Kathleen knows more about them, but I think they use some natural gas to do some of at least the initial heating, and then once they start a production of smoke, they convert to burning that to continue to provide the heat. But most of the smoke they flare off, so it's just burned in chimneys, and if it's at night, it's pretty cool to look at.
I'd love to hear more about how this all fits in with renewable energy, and I'm hearing like a lot about like gas and everything, and how if there's like an offset of using possibly non-renewable energy in biochar production and uses, or how you could possibly connect biochar with more renewable sources.
Yeah.
Go
ahead.
Go ahead.
Oh, in our Northern New Mexico College pilot, one of our partners is the local electric co-op. They were actually the ones who used to sell the propane to the campus, and so they lost a big contract. But they're very progressive, and they've just put in a large solar PV array next to the campus. But the problem with solar is it only works in the daytime, and wind only works when the wind blows. And part of the reason they signed up to be part of the pilot is because they're interested in a generation capacity that can happen anytime, which pyrolysis and burning the smoke, that doesn't depend on daylight or wind blowing. And we are also beginning to work on another application. These biochar boilers are kind of like a Swiss Army knife approach. It's really just a gas making device that makes biochar. And so you can hook them up to all kinds of things to use the flammable gas to either make some kind of energy. And we have a microturbine, gas-fired microturbine that we got at a surplus auction. And right now we're writing a grant proposal. It's actually very specific to doing a ceramic heat exchanger so we can burn the smoke at very high temperatures and generate the wind, you might say, to drive the turbine to make electricity. And this electric co-op is very interested in that technology.
Kathleen, do you want to build on that at all? And also just within the renewable energy question, I would love to hear a little bit more about, this carbon sequestration potential of biochar and, what kind of offsets we're looking at.
Yeah, I mean, as Gordon mentioned, this guy in Boulder, Brett Kincairn, he's been a client of mine for the last few months, and we're looking at the bioenergy biochar opportunity assessment for urban environments. So we've been looking at 2 cities in the US, it's Boulder and Minneapolis, and 2 in Europe, it's Helsinki and Stockholm. And Stockholm was one of the first urban environments to utilize urban green waste to produce biochar, and the heat was fed into the district heating system. And that project was partially funded by Bloomberg, and now they're interested in replicating that in other cities. So I know that Minneapolis they have this really interesting concept for using the heat from the biochar to heat the water in the summertime in some geothermal context. And then that heated water can be used in the wintertime for heating, as can the heat produced during biochar production. So we're seeing a lot more uses for the heat. And in some cases, you can bolt on electricity as well. But I think Gordon mentioned using it in a greenhouse. This is a really smart way to use not only the heat, but there are some systems that are looking at purifying the carbon dioxide that's emitted during the process and using that in the greenhouse to improve, growth rates. So.
Cool, awesome. We had a question that came in that I think is really interesting when it comes to making biochar, and that it's, what is the lower limit of what is considered woody biomass? Would coffee grounds or cannabis stalks be considered woody biomass?
Definitely. And I'm actually working on a couple of different coffee projects right now. I wrote a white paper a few years ago on the benefits of biochar and biochar production throughout the supply chain for coffee. And so, I don't know how much people know about coffee, but for every pound of coffee, like 98% of it is waste. And that doesn't even include the tree prunings. But in the country where you're using the biochar, not producing it, you have coffee chaff, which is 10% moisture content, very flyaway. And then you have the spent coffee grounds, which is 80% moisture content and very distributed. So, the roaster will have all this coffee chaff. It's not going to have a huge energy content to it, but if you end up blending the two, you're reducing the moisture content, so you don't have to use that heat for drying. This is a project I've been working with some senior engineering design students. And then at the production site of coffee, you have the tree prunings, but you also have the milling residues, which is also pretty wet. And it's not generally, they have very poor organics management with that. And it produces a lot of methane. So we're looking at a project in Peru to carbonize that and use the heat in the production process, and then use the biochar to filter the effluent from the process so that you're cleaning up the water that's eventually going back out into local water bodies, and you're actually harvesting them so that the biochar will be loaded with nutrients. So there's all sorts of residues out there that are just going unutilized. I call it unloved biomass. And you can make biochar from most of it. There's pyrolysis for plastics. We don't call that biochar. You can pyrolyze almost anything. But when we talk about biochar, it has to have a certain carbon ratio, but it's actually pretty low. So when you carbonize manure, you're probably going to have about 30% carbon in that material. When you carbonize trees, it's 80 to 95%. So it has to meet a certain threshold of carbon and durability, which I mentioned in my earlier thing, and then also safety. So if you're carbonizing municipal solid waste, you're probably going to have toxins that don't allow it to be considered as biochar.
Sure. I have another question. Is biochar something that people can make at home? People on this call tonight, could they go in their backyards and make biochar, or is it really something that you should be, getting from a professional?
Well, it depends. I mean, yes, I make it all the time. I have my project, which I call my Dwelling on Drawdown project, and it's all about sequestering carbon in different ways in my house. And I have so much excess wood waste from this process. And I tried my hardest to not have wood waste, but I'm turning that all into biochar. And then I'm putting it in to use in different ways in my landscape. So I put literally 1 ton of biochar in my septic system at the bottom, so that, you know, it's filtering any potential nasties or excess nutrients before it gets into the groundwater. And I'm putting it in my dry creek beds and in my drip line irrigation and stuff like that. So yeah, it's very easy. I mean, this came from indigenous cultures. It was really a waste management technique where they, when I was in Peru, I saw them cooking in this style called pachamanca, which is digging a pit into the soil, putting some dry biomass underneath it, and then putting fresh logs across it. Onto that, you would put these stones, and you let the stones warm up, and then you put the heated stones underneath, and you put your food on top of that, and that's their cooking style. Well, at the end, you have a lot of charcoal there, and my guess is that what they did at the end to quench the fire is they brought out all their you know, urine collection systems in the form of pots, and they quenched the fire, and they were actually putting nutrients into the charcoal, and then they would eventually move to another place to do the same thing all over again, and they would plant their seeds in the old cooking pits.
Well, I just want to open it up if there are any last, I have one last question before you guys go, but I just wanted to, you know, open it up, invite anyone who wants to come off mute and ask a final question.
Somebody was asking about bone char, which is,
Oh yeah, Judith asked, yeah.
Yeah, it's kind of interesting. I just heard recently where somebody was producing it at commercial scale. It's a very specific kind of biochar, which has high nutrients. Usually woody biochars don't, but you would get some calcium and phosphates or whatever. I'm not an agronomist, but that I always throw bones in when I'm making biochar at home, because it does add something. But it used to be used for refining sugar way back when. So yeah, it has potential, but I don't see anybody commercializing on that right now.
Cool. Jerry,
Hey,
I saw that.
Kathleen,
Oh.
this is Mike Calicrate. I might just,
Hey, that's the other biochar person I was going to say you all should know more about.
yeah, well, we make bone char out of our bones from our
Awesome.
operation and meat cutting operations. That goes back to St. Francis, where our slaughter occurs and where the animals are raised. And then we char the bones, and it's about equal parts calcium, phosphorus, and carbon.
Okay, interesting.
So we like to pyrolyze the bones, and then they grind up very easily into a whatever size powder or particle size you want. And then we're mixing that into our compost, and we're selling some at our store in Colorado Springs as well. So yeah,
Excellent.
Gardens.
Drop your info in the chat, Mike, if you're willing.
Pardon me?
I said, drop your info in the
Oh, I
chat,
will.
Mike, so
Okay.
people can learn
Yes.
more if you're
Yes.
willing. And then
Okay.
Jerry, I saw that you've had your hand up for a moment, so go ahead.
Yeah, so I have two questions. One of them is about tamarisk or salt cedar as a feedstock. This is a big issue over here on the western side of Colorado, along the Colorado River and other rivers where tamarisk is now being taken out, but it was planned initially in part to extract salt, particularly sodium chloride salts from the water, which you don't really want to put into something that goes back into the soil. And the second question, there's really more of a comment. The thing I worry about with homemade biochar activity is that incomplete burning of the carbon gives you carbon monoxide instead of carbon dioxide. And it's a great addition to synfuel, but it's really not very good for human health. So that's why I'd caution everybody to think carefully about trying to make biochar at home.
Yeah, it is a craft. I mean, you have to learn how to do it, but it's very doable. They've done emissions testing on some of these low-tech methods as well, which I encourage people to, scan through Google Scholar. As to your question about salt something or other, I really don't know. I have no
This is more-
experience.
Yeah, this is more a question for Gordon. Assuming that he actually knows about this particular feedstock.
I do know about it. We haven't tried it yet, but we fully intend to. And then, like you say, we'll have to have it chemically tested afterwards to see if it's good for use, but I'm
Right,
pretty
right.
sure it'd be good for making energy.
Sure, for energy, it's not a problem, but if you're trying to
And-
use it in agriculture, it could be a problem.
And the
And I
carbon,
will
whether-
say, the Colorado Department of Public Health and the Environment really discourages people from making biochar at home precisely for this carbon monoxide problem.
so that one comment I'd like to make, one of my favorite things, which I forgot to do earlier on, is that this, the biochar boiler system where you use all the smoke for energy. And then if you use the biochar in a sequesterable fashion, some people won't want to burn it, but if you put it in the soil or in a building product and it's sequestered for a long time, it actually means we have a truly significantly carbon negative energy source that's also revenue positive. There is nothing else on the planet that's an energy source that can claim to be carbon negative. It's kind of a mind blower, I think.
Yeah, I think that's a pretty critical point. Thanks for making that, Gordon. All right, well, I know we're at time and I really want to be respectful of everyone's time, but before we go, I would just like to ask both Kathleen and Gordon, if there's one big takeaway that everyone on this call could go home with and that could start doing to be a little bit more eco-friendly, be a little bit more soil friendly, what would it be as it pertains to biochar?
Well, from my perspective, what the industry needs a lot of right now are people that can help spread the word to different audiences. It's policy people, it's potential end users in different industries. Gardening's one, but there's a lot of focus right now on stormwater management. And if they can get up to speed and help introduce people to biochar, that would be great.
Great. And you, Gordon?
Well, I'm calling this Volkscarbon, the people's carbon, with the community circular economy idea. And what I would recommend is to find other people in the community who would like to do something like a food sustainability project and include some greenhouses and begin to make biochar and just start doing this stuff. Thousands of people in a community could be actually participating hands-on in one way or another. It doesn't have to be directly making biochar. It could be in growing the food or working with the food bank or farmers markets. But make the whole networked enterprise into an educational event.
Sure. Thanks for making that point. I really appreciate it. Well, thank you, everyone. Once again, our monthly webinar has just flown by so quickly. An hour is never enough time. I really appreciate Gordon and Kathleen and Janice and Rebecca and everyone who helped put this talk together tonight, and all of you for joining. I'm going to go ahead and drop my email in the chat. It's just Michaela@350colorado.org if you want to get in touch with me. Rebecca went ahead and put some links to a donation page for our committee, as well as how you can join and get involved. And then I just want to let you all know that this was being recorded. I'll make it available, and I will also make the chat available, as well as those slides that Kathleen showed at the beginning and any other resources. We can actually probably send out the video as well too that we did. So I will make sure you all get that. Thank you so much, everyone.
Thanks.
Thank you.
Have a great night.
You too.